Bismillahirrahmanirrahim. Assalamu alaikum dear students. Today our topic of discussion is WCDMA wideband code division multiple access. The points we discuss here in WCDMA are the key concepts of the WCDMA, WCDMA background and evolution, WCDMA system specifications, codes in WCDMA, and power control in WCDMA, then the quality of service support by WCDMA, and then we will discuss that what next after 3G. Now, what are the key concepts of WCDMA? CDMA, spread spectrum, direct sequence spreading and processing again. Now, what is CDMA? CDMA can be seen as an application of a technique where the frequency and the time division limitations are eliminated. Two technologies that are previously used are frequency division multiple access and time division multiple access. Here shown in the figure that the frequency division multiple access using different frequencies for different users. It means the frequency is shared. That's why interferences are possible. After that, the time division multiple access technique is used where the same frequencies are used but the different time slots for different users. So it means the time for the users is shared. After that, code division multiple access technique is initialized where the same frequency and time are used for the users but separated the users from each other with orthogonal codes. It means at a time one user is using the whole bandwidth. In wideband code division multiple access, this technology is used. After that, we will discuss spread spectrum. Spread spectrum means that the transmission bandwidth is much larger than the information bandwidth. It means transmitted signal is spread to a wider bandwidth. Actually, from where the concept of spread spectrum comes. Spread spectrum refers to a system originally developed for military applications. So, in military application, in order to provide the secure communication by spreading the signal over a large frequency band. The idea behind the spread spectrum is to use actually the more bandwidth than the original message while maintaining the same signal power. So benefits provided by the spread spectrum are more secure communication because of the larger bandwidth or the communication over the large frequency bands. Also, it reduces the interference impact due to the processing again. Now, the spread spectrum technologies have the following classification. First one, it is implemented by the direct sequence. It means spreading with pseudocode noise (PN) sequence. Also, frequency hopping, rapidly changing frequencies here. And after that, the third classification of spread spectrum is time hopping, where the large frequencies but short transmission bursts. But the most widely and commercially used technique for the spread spectrum is direct sequence spread spectrum. Now, actually, from where the spread spectrum came. First publications were in late 40s about spread spectrum. After that, first application of this technology is in military, as I have already told you. After the military application, cellular applications propose the use of these technologies in late 90s. When it is used in cellular applications, then in late 90s and in 80s, the investigation about the use of these technologies in cellular networks are done. Then the standard IS 95 in 1993 introduces it in 2G technology. In 1997 and in 1998 it is used in 3D technologies as well. Now, In 2001-2002, commercially launch of WCDMA technology and the use of spread spectrum. Now, what is the direct sequence spread spectrum? It is a transmission technology used in local area wireless networks transmissions. In this technology, a data signal at the sending station is combined with a high data rate bit sequence which divides user data based on the spreading ratio. In direct sequence, user bits are actually coded with the binary sequence. It means spreading and channelization code is done. Now, the spreading and channelization code or the bits that are used for the channelization codes are called chips. Chip rate, that is W, is typically much higher than the bit rate. It means the bandwidth is much more larger than the bit rate. After that, codes need to be in some respect orthogonal to each other. Now, what will be the length of the channelization code? Actually, length defines how many chips are used to spread the signal information bits and thus determines the end bitrate. Now, two techniques can be used in channelization code length. First one is shorter code equals to shorter code, that is actually equal to the higher bitrate, but better signals to interference and noise ratio is also required. So sometimes larger codes are used. Also, another problem in shorter code is that fewer number of codes can be generated. So different bit rates have different geographical area covering based on the interference levels. In direct sequence, what we actually doing at the transmission end and what we actually doing at the receiving end is described here. Transmission TX side with DS. Actually here in this side we will do information signal is multiplied with channelization code. It means the spread signal is generated. At the receiving end, spread signal is multiplied with channelization code. Multiplied signal is then integrated, it means summed up. If the integration result is adequately high or low values, it is showing that our required transmission data is received. Now, in direct sequence spread spectrum, transmission side have the following step. First one, a pseudo-random code is generated that is different for each channel and each successive connection so that interference is not possible. The information data modulates the pseudo-random code. After chip vector for 1, inverse for it for 0. The resulting signal modulates a carrier. Then the modulated carrier is amplified and broadcasted. Pictorial representation of the transmission steps are here. Data, it can be digital voice, ISDN data or any other data is transmitted. It is then spreaded by using the channelization code, and then the modulation is done, and after the amplification it is sent to the base station. In the reception steps, the carrier is received and amplified. Then the received signal is mixed with a local carrier to recover the spread digital signal. Again, a pseudo-random code is generated matching the anticipated signal. The receiver acquires the received code and phase lock its own code to it. The received signal is correlated with the generated code, extracting the information data. So at the receiving end, we are actually extracting our required data from the spreaded data. These are the key concepts of WCDMA that we have discussed. Hope students you have learned about the key concepts of the WCDMA, and next we will discuss further about the WCDMA. Thank you. Allah Hafiz.